Hi, chemistry cats! Today we're going to talk about diluting solutions. And this is prompted by the fact that sometimes when I go to make my Gatorade using the powder mixed with water, sometimes I make it a little too strong, like my yellow Gatorade is a little bit too dark yellow. I prefer the lighter yellow, so even if I buy the liquid Gatorade, I'll add water to it. So by diluting a solution, you are going to add water until you get the correct shade or the right concentration of solute that you want. Now, take a moment to think, if I'm adding water, does this change the number of moles of solute that is in my solution? Am I changing the amount of Gatorade powder when I add water to make my Gatorade more dilute? No, if I add water, I am not changing the amount of solute or the amount of Gatorade powder in my Gatorade example. So what really happens is those solute particles will become more spread out from each other, or they become less concentrated. Some words to watch out for if you encounter a dilution type of problem on a test or quiz. If the example says concentrated versus diluted, or original molarity or new molarity, anytime you're changing that concentration or changing the ratio of moles of solute to liters of solution, you're changing your molarity. So just a heads up, those are some words to watch out for. Right. So it really happens here, and I kind of drew this picture that you guys are going to love, of course. So by adding water, we're changing the volume of our solution, and to make this picture a little bit bigger, we're adding water, but we're not changing the amount of solute like we said before. So in this picture, my solute is my yellow Gatorade particles, and you'll notice that in my first beaker, before I dilute it, I have 6 dots there to represent my moles of yellow Gatorade solute. Then I add water to dilute my Gatorade, which raises my water level or raises my solution level, but I still have 6 yellow dots to represent my moles of Gatorade solute after it's diluted. So those yellow solute particles, the same number before and after adding water, they just get more spread out. They become more spread out from each other. They have more liters of solution to kind of float around in. All right, if we're talking in terms of math, we remember that our molarity formula, when we were talking about concentration and molarity, is equal to moles of solute divided by volume in liters of solution. So since our moles of solute stays the same, my N in that formula remains constant. So my N, which is my moles of solute, does not change, so that's going to be my constant while I have a dilution problem. So let's do an example together. If I have 1 liter of a 12 molar solution and I dilute it to 3 liters by adding water, what is the molarity of my new solution? So I like to start by organizing my information out here, as you might know about me already. So I know that I'm going to have an initial solution and a final solution for before and after I dilute. And some of the information given to me in the prompt is that I know my initial molarity is 12 molar. My initial concentration is 12 molar. And I know that the problem is asking me to solve for the molarity of the new solution, so that's my M2. My M2 is going to be my X that I'm solving for, so I'm solving for my final molarity. I do see some volume information given to me in the problem. So I know that my initial volume is 1 liter, 1.0 liter. Gotta get those 2 sig figs in there. And my final volume, the problem tells me that I'm going to end up with 3.0 liters of my new solution. So my V2 is 3.0 liters. All right, this leaves me to solve for N, which N is my moles of solute, and the problem doesn't say anything about moles of solute, but I do notice that for my initial solution, my 1.0 liters of 12 molar solution, I can solve for my number of moles of solute that I have there. So I'm going to use my molarity formula, molarity equals moles divided by volume, and I'm going to solve that problem for my number of moles, my N1. So N1, when I rearrange the molarity formula, is equal to M1 times V1. So I know that I have 12 moles of solute in my original solution. And since all I did in my dilution was add water, my N1 is going to be equal to my N2. The number of moles of solute does not change. So my N1 is equal to my N2, which means that I'm beginning with 12 moles of solute and I'm ending with 12 moles of solute. All right. And now if I look at my final solution information, I know the number of moles of solute, and I know that my volume of solution is going to be 3.0 liters. So now I can solve for my final molarity of my new solution. So again, I'm going to think back to my molarity formula. Molarity equals moles divided by volume. So I'm going to take my M2, set it equal to my N2 divided by my V2, my final number of moles of solute divided by my final volume. And I'm going to get a molarity of 4.0 molar.